Today we are going to take on our second lecture, which deals with force vectors. And first of all, we are going to define certain terms. And let me write in that force vector. Force vectors. We are going to define certain terms when we are dealing with force or vectors. And those are, one, scalar quantity, second is vector quantity. And what is scalar quantities? These are quantities that have just magnitude. They have just magnitude but no direction. That is, they have a sense of simply a number without direction. Example is mass. It has magnitude but no direction. Mass. And what is mass? Mass, as we have done in the first lecture, is simply the quantity of matter contained in a body. We know that matter is anything that has weight and occupies space. So, scalar quantity are quantities that have magnitude but no sense of direction. And then the second one is vector quantity. And what are vector quantities? They have both magnitude and direction. And in scalar quantities, there could be positive or negative value. They could be a positive or negative value. So, and then in vector, it has quantities, there are quantities that have magnitude as well as direction. An example of them is velocity. For examples of scalar, we have speed, we have mass, we have things like temperature. These are scalar quantity, because speed gives you, it is the rate of change of distance moved with time. That's all. No direction. Where is it moving? It didn't specify. Therefore, it is a scalar quantity. Mass is the quantity of matter contained in the body, whereas temperature is simply the degree of hotness or coolness of a body, taken from a reference point. So it doesn't give you a direction. And then vector quantities are those that have magnitude and direction. Example is velocity. Velocity is a vector. Another one is acceleration. Acceleration is a vector quantity. Force is a vector quantity. And then another, velocity is the rate of even displacement. These are all vector quantity. Well, let's start from here. Displacement is distance moved in a specified direction. That is displacement. Then whereas we have velocity, velocity is the rate of change of distance moved with time in a specified direction. Otherwise, we can call it the rate of change of displacement, since displacement is distance moved in a specified direction. So velocity is the rate of change of distance moved in a specified direction, or the rate of displacement. While acceleration is the rate of change of velocity with time. The rate of change of velocity with time. How is the velocity changing with time? And then force, which denotes a push or a pull in a particular direction. We know that, as I said, our force is given as MA from our first lecture. So where M stands for the mass, which is a scalar quantity, and acceleration is a vector quantity. Therefore, it makes force a vector quantity. Acceleration, the rate of change of velocity with time. And then next is to deal with vector operation. Vector operation. Vector operation. Vector operation. One of them we want to look at is multiplication. Multiplication of a vector by a scalar quantity. When we multiply, the vectors can be operated by multiplying a scalar quantity by the vector. An example is this. If I say an object is moving with a velocity of 2 meters per second, and I decide to multiply that 2 meters per second by 10, it makes the velocity 20 meters per second. That is, I have increased it 10 times. And the quantity 10 is a scalar quantity. But once it is multiplied by a vector, the vector takes the new magnitude, which is 20. We look at example like this. If we have a force, let me say A, of 1 unit this way, and then I double it up. I double it up by see that this becomes 2A. If this is A, this becomes 2A. Or it could be this way. You see the arrowhead now pointing this way. This is minus 2A. I can multiply the vector by a lower quantity, which, take for instance, this. This is 0.5A this way, or it could be this other way, minus 0.5A. That is dividing the vector by a factor. So you either multiply a vector by a large number or a small number. So this is one of the ways of operating vectors. The second one, let's look at vector addition. Number 2, vector addition. Vector addition. We have, normally in vectors, they are represented graphically by arrowheads. If we say an arrowhead this way, the length of the arrow represents the magnitude, whereas its direction, let's say this, from a reference point, if this is our x, this is our y, and it acts here, this angle here, measured counterclockwise, gives the direction of the vector. The length represents the magnitude. Then from any a reference point, which is this horizontal point now, measure counterclockwise. It gives you its direction. And so, in this case, when we want to do vector addition as the second operation, if we have two vectors, we have two vectors, vector A acting this way, vector A is acting this way. And then we have another vector acting this way, vector B acting this way. If we want to add these two vectors, what do? We represent them. You see that the origin here, this point of this origin is called the tail. And then this one, the head here is either the tip. It's called the tip. In this case, the two vectors will be added tail to tail. And we use methods of adding or subtracting. One of the first methods is the parallelogram rule. So if we add these two vectors together, we are going to have a resultant. The addition of this and this will give us a resultant. In this case, what do? These two vectors are acting this way. The parallelogram rule says we should draw a imaginary vector here, which is parallel to this, B, from tail to tail at this point, and then the next one is vector this, which is parallel to this, is from the head of B, we draw a vector parallel to A at this point. So when they come here, they intersect. There's a point of intersection of these two. From here, you draw a line which forms the resultant of these two forces. You are adding the forces together. So this forms the resultant called R. That is the resultant of the addition of these two forces. So from here, we can use this as the resultant. We have this. We have this. This forms a resultant, and this one represents our A. This one is our B. And then this forms a triangle. We either use two methods, either the sine rule to get the resultant or the cosine rule, depending on the available data in this case. And then we could also have the subtraction. This is the parallelogram rule, and we can have the triangular rule. From here, we have extracted a triangle out of here. So we can work with this, add them or subtract, depending on the, if we are adding, you see that the arrowhead in this case, it comes this way. If we were to add, this force was acting this other way. So we could subtract them, still using the parallelogram rule or the triangular rule to solve that. And then, if we have a special case where the two forces, A and B, are collinear, that is, they are acting on the same line, they have this, both of them have the same line of action. It is determined this way. What do I mean? The two forces, A and B, are acting, have the same line of action. Let's say we have vector A running this way, and then vector B also, if this is A, and vector B, all of them acting in the same line, they have the same line of action. So I will simply add them by doing this. A ending here, and then B going here. You see that the two forces is a single line now, because they are co-linear, acting in the same line. So you add A and B. This is A plus B in the case, and then this forms a single resultant, because the addition of these two forces is to give us a resultant. And then the next one is vector subtraction. Vector subtraction. The first we have added. The third one now is vector subtraction. Vector subtraction. The resultant difference between vectors A and B may be expressed as this. In this case, we have that arrow prime is equal to A, vector A minus vector B, which is the same thing as vector A plus into minus vector B to have a resultant, which is still the same way like we did before. And then the number 4 is resolution of vectors. The resolution of vectors. The vector may be resolved into 2 components by having known line of action by using the parallelogram rule. What do I mean? Example is if arrow is to be resolved into, in this case now, we have, let me say, this and this way, and you have this as resultant. The resultant here. You have A and B, and this is R. You are given just R. A and B, you have a resultant given to you. You don't know A nor B. What do? That is where we say resolve it into the horizontal and the vertical component. You resolve it. From here, the direction is given, so we can, as we go further, you see how we resolve it. You can, from the resultant, get back the 2 forces that formed it. That is resolving, resolution of vector. When we get to solving some examples, we will see. Finding the resultant of a force by constructing a parallelogram, that is addition. We use addition of forces and vector addition. We look at a simple example. And how do we solve this? You know, initially we just simply say we have these 2 forces here. We get a triangle out of them, or a parallelogram. From here we have this. This is our B, this is our A. We have a sense of angle here, and this is our resultant. From here, we can use the sine rule or the cosine rule, depending on the available data to us. From here, we see that we have angle theta that A and B are formed together to get the resultant. And even this, we can call this alpha, we can call this beta. In this case, if the resultant is given and this are not given, using the sine rule, which is a mathematical distinction, so we have a resultant here. We can use from here. We say, remember in mathematics, remember the sine rule. You have that A over sine alpha, say A over sine alpha is equal to B over sine beta is equal to R all over sine theta. From here, having these identities, you can find whatever you are looking for in this triangle, either combining this and this. If alpha, beta are given and B is given, you can find A or any other value. If B is given, this is given, this is given, this is not given. We can also evaluate using the sine rule to get our answer. So we'll look at, and then the resultant. The resultant, if we have from here, we either use this sine rule or the cosine rule. In the cosine rule, we are told that, you see, this, we have r squared is equal to the side opposite this is called small a, and the side opposite this is small b. R squared is equal to a squared plus b squared minus 2ab cos r. In this case, it's r, which is opposite the cos r or cos theta. This is the side opposite that, which is cos theta. From here, we see that our arrow alone, which is the resultant, is given as the square root of a squared plus b squared minus 2ab cos theta. So to get the resultant. In any case, any of them that you can substitute to get any of them from the available data that you have. So the resultant is given as this identity here. So we move further. Let's move forward and see some examples to solve. Let's look at the typical example. They say, determine, we have something like this, have something like this, and then have force here, angle formed here is 60 degrees, and then the magnitude is 8 kilonewton. And in this case, we have the angle here 40 degrees and 6 kilonewton as the magnitude. The question says, determine the magnitude of the resultant and the direction measured from horizontal line. Determine the magnitude of the resultant and the direction measured from the horizontal line. So this is the horizontal line. So the first thing we do is to construct a parallelogram. These two forces, what do we do? Look at the 8 kilonewton. We draw the force here, 8 kilonewton, acting this way, and then this one here, 6 kilonewton, 6 kilonewton, 6 kilonewton. Here is 60 degrees, and here is 40 degrees. And then we will construct a parallelogram. From here, we get this line from here parallel to this one here. This one parallel to this. From here, the point of intersection here gives this. This is our arrow. From here, what is the angle here? This is 40 degrees, this is 60 degrees. We know that this is alternate to this, is 60 degrees. And this one here, you see the value of this angle is 40 degrees, whereas this is also 40 degrees. From here, we can extract a triangle. A triangle crosses from here. Here will be angle 100 degrees because 60 plus 40 is that. And this one here, this value is what? 8 kilonewton. And this one is what? 6 kilonewton. So we have our R. We are looking for this angle here, theta. But they say, the question says we should calculate the direction measured from the horizontal line. From here we see that the angle we are talking is this angle here. This angle here. But then it's from here to here. The resultant measured from this horizontal line from here. So when we get the total angle here, we will subtract this angle which is known from the total here. We get our resultant. So now we get into solving. What do we do? From this triangle we have here, we are going to solve them. Which rule can we use? If we say we'll use the sine rule to get this, we have just one angle, and we don't have this angle. So if we say this over sine this is equal to this over sine this, which we have a known angle, we don't know r, so we can't apply the sine rule. If we say we are using this and this, we don't know this angle, so the sine rule is taken out. So the only rule we are going to use here is the cosine rule. And where we have here, we know that we have our r squared is equal to 8 squared plus 6 squared minus 2 times 8 times 6 cos 100 degrees. Cos 100 degrees. So we are going to punch our calculators to find out the values of this, and then finally our r alone is equal to the square root of 8 squared plus 6 squared minus 2 times 8 times 6 cos 100 degrees. I think we can wipe this out, or we still leave it. Then we have to punch the calculator together to get this value. Remember, the angles are in degrees, not in radians. Often students will make mistake by when your calculator is in the radian mode, you start punching this value. The angles in radian are different from the angles in degrees. So you have to be very careful. In this case, we have the square root of 64 plus 36 minus 16. If we multiply this, let's use our calculator. 2 multiply 8 multiply 6 equals 96 minus 96 cos 100 degrees. We are still doing little by little. We have 64 plus it, which is equal to what? 100 minus 96. Let's find the value of cos 100 degrees. Cos 100 degrees is equal to minus, we have minus 0.1736. Add value. Let's multiply it by 96. 96. We have this is equal to 100 plus, because minus multiplied by this, if we factor it, it turns to plus. So we have 16.67. And then if we add them to 100 plus 100 is equal to the square root of 116.67. We have 10.8. So the final answer is 10.8 kilonewton. So the resultant of this, the resultant is equal to 10.8 kilonewton. And we come back to our diagram. Come back to our diagram after taking this down. Come back to our diagram and see what we are going to do to find out that angle, because it was, we have our diagram look like this, and then this was our, so this is the angle we had before. It was extended down. We have 6, we have 8, we have our arrow, and then our x. So to find theta from where we, this is not well drawn as it is, it's not perfectly drawn. Let me put it back so that we have this 60 degrees, and then 40, this is 40 degrees, and then we draw a parallel line to this, parallel line, this, then this parallel to this. You see that it meets here. The actual, this thing is here. This is our x. There is an angle, an extension line theta is equal to, the resultant has been calculated to be 10.8. The resultant arrow is 10.8 kilonewton. So this our resultant is now known, which is opposite angle this. It's 10.8 all over sine 100 degrees. So we use our calculators to punch out now. So we are looking for sine theta. And we have that sine theta is equal to 6 sine 100 degrees all over 10.8. And then our theta alone is equal to the sine inverse of 6 sine 100 degrees on 10.8. So this gives us sine 100 degrees, sine 100 degrees is equal to, we have 6 times 0.9848 on 10.8. So let's solve this out. Multiply 6 and divide by 10.8. We have 0.5471. Then this sine of that is equal to what? It gives us 33.17 degrees. But then, which means that you see the resultant tends to come down here. There's a value of this angle. Since you are starting from the horizontal, and I told you it's counterclockwise from here to here. But we see that if the whole of this is 33, and what is the value of this? From our diagram here, initially you see, if at the x from here, 60 is taken out, what is left here is supposed to be 40. Because this is, it's 30, 90 degrees. from here to here, this is supposed to be angle 90 degrees, but it has increased. It's more than 90 degrees. So if you take out 60, you are left with 30. If 30 would have made it 90 degrees, but it has extended. So we are going to subtract angle 30 degrees from there. We have 33.17 minus angle 30.00. We have 3.17 degrees. So from the horizontal line, so that gives us the angle, the direction of the resultant from the horizontal line. Let's look at another example. A question is then asked. From this same question, we are asked, we do another calculation. It says, determine the angle theta so that the resultant force is directed horizontally to the right. Also find the magnitude of the resultant. Here is that initial diagram. What they say now is this. We have this. We have this. This is angle theta. But the resultant is to act in this direction. Therefore, if it acts here, from here, we have, this is our, from here we have this. We have this, which is our 6 kilonewton. We have this as our R. We have this as our 8 kilonewton. The resultant is acting directly through the horizontal line to here, which means the value of this angle is known. Okay, it's not known. We are asked to determine this angle and the magnitude of this. So we draw out this diagram, this one, bringing it out this way. Resultant. This way. In this case, let's call this angle alpha. We don't know it. If we want theta, theta is not known. Let's call this alpha. And then our resultant is R. We have our 8 kilonewton. We have our 6 kilonewton. And then, what of the value of this angle? We don't know this angle. Let's call it theta. But what of this angle? We should know it. And its value is 50 degrees. The angle is 50 degrees. Some may ask, how did we get at this 50 degrees? From here, remember, this is 40 degrees. We don't know this, but we have known if we draw something here, we should know the value of this angle. We should know the value of this angle. So, if this is 50 degrees centigrade, 50 degrees, we have that we can use any of these, either sine rule, this over this over sine this. Can we arrive at any reasonable answer? Yes. We have 8 over sine 50 degrees is equal to 6 all over sine alpha. In this case, 6 over sine alpha, 8 over sine 50 degrees. And then we can get our sine alpha. Our sine alpha is equal to 6 sine 50 degrees all over 8. This is equal to 6 times 0.9. 50 degrees is what? Let's look at this. Sine 50, which is 0.7660 on 8. We multiply that by 6 and we divide it by 8. Gives us 0.574533. And then this is sine alpha, which is 0.57445. Then alpha alone is equal to the sine inverse of 0.5745. So the value is 35.07 degrees. So we have this angle to be 35.07 degrees. What next do we do? Remember, we have not known the magnitude of the resultant now. So from this identities, from this triangle, we can also find our resultant. But our resultant, we don't know this angle. We don't know the value of this angle. We can still use the sine rule to find it. Or, yes, we can still use the sine rule to get this angle. Or we add this together and subtract from 180 degrees. We are going to have theta, because we have that theta plus alpha plus 50 is equal to 180 degrees, which is the sum of the angles in a triangle. So we have known, we are looking for theta. Therefore, our theta alone is equal to 180 minus alpha plus 50 degrees, which is equal to 180 degrees minus our alpha is 35.07 plus 50 degrees. We add them plus 50 is equal to that, which is equal to 180 degrees minus 85.07. So, which is approximately, in fact, is 94.93 degrees. This angle theta is 94. Theta is 94.93 degrees. We can now get our resultant. The value of the resultant will be what? Using the sine rule, we can say, using the sine rule, we will say R all over sine theta. Our sine theta is 94.93 degrees is equal to, we have known our 8 all over sine 50 degrees. Those are known. Therefore, our R alone will be equal to 8 sine 94.93 degrees all over 8. This is equal to 8 times 0. What was our value? Sine 94.93 is equal to 0.9963 on 8. Huh? Made a mistake. This is 8 times all over Oh, no. Yes, all of us sine 50. We made a mistake. All of us sine 50 degrees. That was a mistake. So, we multiply this by 8. It's equal to 7.9, which is equal to 7.97 all over sine 50 degrees. Sine 50 degrees. It gives us 0.7660. This is equal to 10.40 kilonewton. So we have now gotten the value of the resultant in this case is 10.4 kilonewton. Can we find another example? We find another example to solve. One more example, then we can call it off for this. It says resolve the. There's another example here. The question says resolve the 50-pound force into components acting along X and Y axis. We have this. We have this as 65 degrees. And have the force acting there. We'll call this as X direction. And then we have here, I have this as 60 degrees. 50 pounds. This is it. And then this we call Y prime. Have 65 degrees. Here will be 10 degrees. This is our Y. So, we draw the diagram here. Our X is here. This is 60 degrees. 50 pounds. Here is 50 pounds. And then here is our FY. Our FY is direction. Write the free body diagram this way. This way, which is 60. We have our FX here. Have our FY here. Yes. 80 degrees. So we have from this triangle, we have 50 over sine 90 degrees is equal to fx over sine 60 degrees. Remember, this is 50 pounds. From here we have that our fx is equal to 50 sine 60 degrees all over sine 90 degrees. Use our calculators to punch our calculators. From here we have 50 times sine 60 degrees times 60 degrees is equal to 0.8660, and sine 90 degrees is what? 1. Multiply 50 equal to sine 90 degrees is 1, which is equal to 43.30 pounds. 3.30. Let's confirm whether sine 90 degrees is sine 90 degrees is equal to 1. Correct. So we have that, and then our fy prime, fy prime here is equal all over sine 60 degrees is equal to 50 all over sine 100 degrees. 100 degrees. This plus this is what? 90 degrees. We have fy prime is equal to 50 sine 60 degrees all over sine 100 degrees. Punch our calculators. Fy prime is equal to 50 multiply sine 60 degrees. Sine 60 degrees is 0.8660 all over sine 100 degrees for 0.9848. Okay, so we find out 50 multiplied 0.866, which is equal to 43.3 all over 0.9 divided 0.9848 equal. The final answer is 43.968, which is approximately 43.97 pounds. We will call it a day here for today. Look forward to our next lecture, and remember to subscribe to this YouTube station so that when the next video comes up, you will be alerted.